Welcome everyone. So in our last lecture we were introduced to quite a number of new formulas. So before we proceed, I would like to tell you a bit about formulas in mathematics or physics or anything you study. The formulas or equations, they always represent a story. They try to tell you a story through the variables involved there and the way the variables interact with them. There is always a story behind it. You never need to memorize a formula. Just understand the story behind it. Try to understand what the equations, what the variables represent, and what story is the equation trying to tell. Just try to understand that logic, and then solve a few examples based on that formula. And when you do that, connections will get modified in your brain, and it will logically understand the formula and you can use it every time. So even after a long time, if you forget the formula, you just try to recall the logic that was behind the formula, and the formula will automatically flow into you. So that would be my advice, and that is how we will have a relook at the formulas once again. So the very first formula that we had was for the nth term of an arithmetic progression, and it was given as Tn is equal to a plus n minus 1 times t. So the way I think about this formula is that by the time you reach the nth term, you would have added the increment n minus 1 number of times. That is, you start with a, so by the time you reach the second term, you add the fixed difference or the common difference one time, so a plus t. You reach the third term, so you would have added the common difference two times, that is 2d to the first term. Similarly, for fourth term, you would have added the common difference three times, and so on. When you reach the nth term, you would have added the common difference n minus 1 number of times to the first term, and from this you get the general formula for the nth term of an equation. The second thing that we derived was the sum of n terms of an arithmetic progression. So if these are the n terms of an arithmetic progression, what would their sum be? So the way we write that formula is, if we add the first and last term, what do we get? 2a plus n minus 1 times t. So it is 2a plus n minus 1 times t. This is simply the sum of first term and last term. And now we also noted that if you add the second term and second last term, a plus d plus a plus n minus 2 times d, you would again get this thing, 2a plus n minus 1 times d. Similarly, if you add the third term and the third last term or third term from the end, you would again get this sum. So if you keep on doing that, and if you need the whole sum, so we would be adding this expression half the number of times there are number of terms. So the first and last becomes this, the second and second last becomes this, the third and third last becomes this, and so on. So we will be adding this half the number of times there are number of terms. Therefore the total sum will be this term, that is first term plus the last term, 2a plus n minus 1 times t, multiplied by n by 2, that is half the number of terms that is there. This was our second formula, which we can also think as n by 2 times a plus n minus 1 times d. And if there are only n terms in the arithmetic progression, then this thing here would be our last term. So you can also think of the sum as n by 2 times a plus l, last term. If there are n terms in the equation, then the nth term will be the last term, and the sum you can write as Sn is equal to n by 2 times first term plus last term. And one more formula that we saw as a remark was if we have to find the nth term of an equation, then how do we do it? So if we know the sum of n terms, then we subtract sum of n minus 1 terms. So if we let's say know the sum until this number, until the nth term, and we subtract from it the sum until one term before it, sum until n minus 1th term. So the term that will be left is the nth term. The way you can think about this formula is that if you know the sum until n minus 1th term, that is one term before this, and then if you add this term to it, tn, you will get the sum until nth term. So if you know Sn and Sn minus 1, you just have to subtract it and then you get this formula. So these are the set of formulas that we need to keep in mind. And now we will solve some examples using these formulas.